Assalamualaikum. My name is Muhammad Aiman Daniel bin Zafaruddin. My matrix number is CD20086. Okay, I will explain about introduction. A numerical method is a comprehensive set of specified steps with calculable error estimates for addressing a problem. Numerical techniques can be used to generate an approximate solution. Nevertheless, if the boundary conditions are known, these processes are frequently much easier when performed on a computer. In the field of science, metrics can be essential. Metric application can currently be found in nearly every field of engineering science, including communication, banking, the military, also computerized local, and so on. These are referred to as eigenvector. The transform vector produces a new vector that directly corresponds to the original vector. The term eigenvalue refers to the scalar quantity by which the original vector is expanded. Okay, we continue to the real world problems. There are 5 real world problems that can be linked with the topic of the eigenvalue and eigenvector. The first is in a mechanical engineering problems. Secondly is when contractor building a bridge of construction. Next is the vibration of two objects which are washing machine and air dryers. Fourth is PID power control system, and lastly is when to create or design automobile stereo system design. Eigenvalue and eigenvector should be emphasized for all of these problems. In our research, we choose to study the real-world problem about the number 3. Is it the two objects which the washing machine and air dryers? Because it is closely related with our daily life.
Assalamualaikum, my name is Nur Shahira binti Salihin and my metric number is CD 2031. So I will talk about manual calculation and also the result of this calculation. First, this is the free body diagram of stackable washer and dryer, and this is the table or details of parameter, which consists of M1, M2, K1 and K2. So then we will go to the equation of motion, total F equal to MA. After we extract all the information from the free body diagram, we will get equation 1 and equation 2. After that, we will divide equation 1 with M1 and equation 2 with M2. So after we divide equation 1 and equation 2, we will have equation 3 and equation 4. Next, we will transfer all the information into matrix A form and put all the value from the previous table into the matrix A. Then we will get this matrix. So next, we assume harmonic motion, that is x equal to v sine omega t. X double dot equal to negative omega square v sine omega t. Then we put since we assume this is harmonic motion, we will be using this metric. Then rearrange metric A minus lambda metric I equal to 0, which is lambda is equal to negative omega square. Then after we arrange it like this, we will subtract metric A into metric A equal to lambda, M minus lambda. So after that we will have this metric. Then we will use Cramer's rule, 7.0922 minus lambda times 4.8077 minus lambda minus negative 1.7730 times negative 4.8077 equal to 0. Then we will get 34.0972 minus 7.0922 lambda minus 4.8077 lambda plus lambda square minus 8.5243 equal to 0. Then we rearrange it and write in higher order. lambda square minus 11.8999 lambda plus 25.5731 equal to 0. We will do quadratic equation using calculator, which is lambda 1 must be smaller than lambda 2. So after that we have lambda 1 equal to 2.8149. Meanwhile for lambda 2 we get 9.0850. Next, since lambda is equal to omega square, so omega 1 square is equal to 2.8149. Then we square root 2.8149, we will get 1.6778 radian per second. Same with the omega 2 square. So we square root 9.0850, we will get 3.0141 radian per second. So to find the eigenvector, we have to recall the previous matrix, which is this matrix. Then we will substitute into this equation. 7.0922 minus lambda times V1 minus 1.7730 times V2. After we rearrange it, we will get V2 is equal to 2.4125. So for the first eigenvector, we have 1, 2.4125. Next, for lambda 2, eigenvector 2, we assume V1 also equal to 1. So 7.0922 minus lambda V1 minus 1.7730 V2. We rearrange it. We will get, for the V2 is negative 1.1240. So for the eigenvector 2, we will get 1, negative 1.1240. Thank you.
Hi, Assalamualaikum. My name is Muhammad Shakir bin Aminwa, and my matrix number is CD200179. So today I want to discuss about the validation of free mat that we have from the result that we have done. So for the lambda 1 we get 2.8149, and for the lambda 2 we get 9.0850. So that's same as calculation, and the eigenvector we got 0.3829 and 0.9328, and we change to 1 at the eigenvector, and we got the same for eigenvector 1 and the eigenvector 2. So this is how I do a validation using the free mat, which is I input the matrix A and I do the eigen, put the VD eigen A. So we got the V and D. So V is lambda, V is eigenvector, and D is lambda. So next, this is the graph for eigenvector 1 and eigenvector 2, which is eigenvector 1 all are at the positive side, which is 1 and 2 and 2.41, and eigenvector 2 one at the positive side and one at negative side, which is negative 1.1253. So this is how the graph. Thank you.
Overall, the percentage of error between the calculation and the validation result is 10%. From the result of percentage error as shown in Table 8, it can be justified that the validation task create positive outcome by proving the answer of manual calculation. As a discussion, we might go over how metric might be used to solve this issue in the real world. Prior to selecting metric as the method of solution to be employed in answering real-world problems, it was necessary to ignore the pointers supplied by the question. First, improper isolation will result in decreased production, and if it isn't fixed, the machine might get damaged, which would finally lead to system failure. Therefore, evaluation of the natural frequency, mood shape, and isolation zone is crucial to understanding the issue that exists in the isolator pad and recommending a fix. A 2 degree of freedom method can be used to represent the stacking wash and dryer with isolator pads underneath each machine. The eigenvalue and the eigenvector must be calculated to reduce the vibration and make the lifetime of machine much longer.
Assalamualaikum and hi, my name is Muhammad Syarul Syafiq bin Marzuki and my matrix number is CD200113. For the conclusion for this group project regarding the vibration of the stacker washing machine and dryer, we managed to calculate the mode shape and the natural frequency for this system using the eigenvalue and eigenvector. And for the conclusion also, we have been validated by using the free mat and no error occur in the free mat. We also can implement what we have learned in class in this group project. Okay, next. For the reference, there are several references that have been used in order to complete this group project. Okay, thank you.